Hello everyone, welcome back to the second part of the real numbers. So this part consists of arithmetic theorem, fundamental arithmetic theorem followed by prime factorization method and finding out the LCM and HCF using these prime factorization methods. So the first topic is fundamental theorem of arithmetic. So what does this fundamental theorem of arithmetic states? It states that every composite number can be written as a product of powers of prime. So I will give you I will explain you with an example. So let us take an example. I had assumed some composite number. Let it be 32340. So now we already learned the prime factorization method. We can write it in the prime factorization method. So I divided this 32340 with 2. I will get it as 16170. Now again we can divide this value with 2. So by dividing it with 2, I will get a value of 8085. Now it cannot be divided with 2. So the next prime is 3 and let it be 5 also. So by taking 5, I will get it as 1617. Again, now it will not be divided with 5, but the summation of these digits is 7 plus 1 8, 8 plus 6 14, 14 plus 1 15. So 15 is divisible by 3. So this value 1617 is divisible by 3. So now I will divide this 1617 with 3. I will get a value of 539. Now the next by again this value will not be divided with 3. By adding these digits, it will be 9 plus 3 12, 12 plus 5 17. 17 is not divisible by 3. So the next one is 7. So now by dividing this 539 with 7, we will get a value of 77. And again this 77 is divisible by 7, we will get a value of 11. Now by writing this 32340 as a factors, product of some factors, we will get a value of 2 into 2 into 5 into 3 into 7 into 7 into 11. So which states that every composite number, the composite number here is 32340. So every composite numbers can be written as a product of powers of primes. So here this 32340 can be written in the form of a product of powers. Here 2 square, 3 and 5 and 7 power 2 and 11. So these are primes. So this 32340 can be written in the form of product of primes. Now so the first topic is express each number as a product of prime factors. So these are the given numbers. We should write all these in the product of the prime factors. The first one is 174 here. So this 174, since the last digit is even number, it can be divisible by 2. So by dividing it with 2, the value will be 87. So again this 87 cannot be divided by 2. So I will check it with 3. Sum of the digits is 8 plus 7, that is 15. So 15 is divisible by 3. So 87 will also be divisible by 3. So I am dividing this 87 with 3. I will get a value of 29. So this 29 cannot be divisible by 3. Since 9 plus 2 is 11. 11 cannot be divisible by 3. This 29 cannot be divisible by 3. Now the next, so this 29 cannot be divisible by any other number. So our product of prime factors of this 174 is 2 into 3 into 29. Now coming to the second one, the question is 156. So this 156, again, since the last number is even, it can be divisible by 2. So this, by dividing this 156 with 2, I will get a value of 78. And again the last number is even, so it can be divisible by 2 again. So by dividing it with 2, I will get a value of 39. And this 39, since it is a product, the sum of these digits is 9 plus 3, that is 12. It can be divisible by 3. So I am dividing it with 3. I will get a value of 13. And 13 is a prime number, so it cannot be divisible by any other number. So finally the product of primes of this 156 is 2 into 2, that is 2 square into 3 into 13. Similarly, coming to this value 8436, it can be divisible by 2. So by dividing it with 2, I will get a value of 4218. And again it can be divisible by 2. So by dividing it with 2, I will get a value of 2109. And the sum of the digits of this 2109 is 9 plus 1 10, 10 plus 2 12. So it is divisible by 3. By dividing it with 3, I will get a value of 703. And finally, by checking all these numbers, this 703 cannot be divisible by 5. And the next prime is 7, and also it cannot be divisible by 11, 13, 17 also. Finally it can be divisible by 19. So by dividing it with 19, I will get a value of 37. So this 8436 finally can be written as 2 square, 2 into 2, 2 square into 3 into 19 into 37. So this is how we can write every number as a product of some prime factors. Now the second question is find the LCM and HCF of numbers, HCF of the numbers using prime factorization. So the question is, first one is 24 and 180. So now I will write this 24 and 180 as powers of prime factors. So coming to this 24, it is divisible by 2. So 2 into 12 is a factors of this 24, and the factors of 12 again it can be divided into a tree of 2 into 6, and this 6 can be again divided into a tree of 2 into 3. So finally the product of this 24 can be written as 2 into 2 into 2 into 3. Now coming to this 180, this 180 can be divided by 2, so it can be written as 2 into 90, and this 90 can again be divided into a tree of 2 into 45, and this 45 can be divided into a tree of 5 into 9, and again this 9 can be divided into a tree of 3 into 3. Finally this 180 can be written as 2 into 2 into 5 into 3 into 3. So now coming to LCM and HCF. What is HCF? To find HCF, find any prime factors that are in common between the products. So here the common factors here and here are, for 24 there are 2 2's. Again here 180 also had 2 2's, and we had another common factor between 24 and 180, that is 1 3. So finally the common values are 2 into 2 into 3, that is 12. So the HCF of this 24 and 180 is 12. Now coming to LCM. LCM is the product of greatest power of each prime factor in the numbers is called LCM. So the product of each prime factor. So here what are the prime factors of 24 and 180? 24 has 2, 3, and 180 has another one with along with 2 and 3, that is 5. So the highest power of 2 is here 2 power 3, and here it is 2 square. So LCM is a product of highest powers. So it can be written as 2 power 3, and coming to 3, here it is 3 square and here it is 3. So we can take 3 square, and coming to 5, here it is 5 power 0 and here it is 5. So 5. Finally multiplying these values, we will get a value of 360, which is the LCM of these two numbers. Now coming to the second example. The question is 12, 15 and 21. Now coming to 12, it can be divided into a tree of 2 into 6, and this 6 can be divided into a tree of 2 into 3. So the factors of this 12 are 2 into 2 into 3. Coming to 15, it can be divided into a tree of 3 into 5. Both are prime numbers. So the product of the prime factors of this 15 is 3 into 5. Coming to 21, it can be divided into 3 into 7. Sorry, here it is 7. Change it as 7. Now this 21 can be divided into 3 into 7. So this is the factors of this 21. Now coming to HCF. HCF is the common factors. So here the common factor in all the three numbers is only 3. So the HCF of all 12, 15 and 21 is 3. Coming to LCM, it is a product of highest powers of the prime factors. So coming to this 12, we had prime factors here are 2 and 3. Coming to this 15, 3 and 5. Coming to this 21, 3 and 7. So the highest power of 2 in all these 3 is 2 power 2. And coming to 3, the highest power is 3 power of 1. Coming to 5, here it is 5 power 0, here it is 5 power 1, here it is 5 power 0. So 5 power of 1. And same as 7 also, we had only 1 power, that is 7 power of 1. By multiplying this, we will get a value of 420. This is how we will find out the LCM and HCF using prime factorization method. The next one is check whether 4 power of n can end with a digit 0 for any natural number n. So simply we had a we can write this 4 power n as 2 power of 2n. But here for ending a digit with 0, with 0, it should be divided. It can be divided with 5. Simply for any number, if it is divided with 5, so it ends with 0 or 5. So for ending with 0, it should be divided with 5. But I have simplified this 4 power of n as 2 power of 2n. But this 2 cannot be divided with 5. Okay. So which means that 4 power of n cannot end with 0 for any natural number n. Next question is, how will you show that 17 into 11 into 2 plus 17 into 11 into 5 is a composite number? So no need of simplifying this one. I mean, no need of calculating the total value. Just by showing a number as a product of 2 or 3 prime numbers, it defines that the number is not a prime number, it is a composite number. So simply here I am taking this 17 into 11 as common. This is our question, so I am taking 17 into 11 as common. So which means that 17 into 11 into 2 plus 5. So by adding this, we will get a value of 17 into 11 into 7. So which means that this number is a product of 3 prime numbers, which is definitely a composite number because it had 3 prime numbers as the factors. So thank you. Please subscribe for more videos.